When you die, not one of your atoms will ever disappear. They just go from one level of organization to another. They go from one scale to another. Now I'm telling you that your atoms are mini black holes. Is that crazy? Actually not. Some of the largest, most comprehensive unification theory that are trying to be worked out now, and are incorrect because they're missing the fractal component, by Stephen Hawking, for instance, describe all subatomic particles as mini black hole, and the Hadron Collider that's being built in Geneva that I mentioned earlier is being built to search for these mini white hole black holes for subatomic particles. One thing that's really exciting that I discovered lately is that I'm telling you that the atoms that makes up your cells are mini black holes. Well, that's true. But another resolution is the cell itself. When you look at the surface of a cell, a biological cell, it has a grid on it. It has a mesh on it that holds the event horizon of the cell, that holds the membrane of the cell together. That is called lipoprotein. The rate of oscillation in hertz of the lipoprotein on the surface of a cell is 10 to the 11 hertz. That's 10 with 11 zeros hertz. That's how fast it vibrates, the cell. If you plot the cell at 10 to the 11 hertz and plot the radius of that cell, then you end up in the exact middle of the graph. And you have all of the biological resolution right there in the middle of the graph. And I'm not publishing this with this first publication of this paper because it's a little too esoteric. You don't want to freak them out all at once, you know? It's bad enough, you know, that you're telling them everything is a black hole. But the cell actually, the cell biology, the biological resolution actually obeys the Schwarzschild condition of a black hole because it generates so much energy. 10 to the 11 is a huge number. The other thing that confirms that this scaling law is correct is that when you look at the distances between each of the data points on the scale, oh, by the way, you know, these should fall everywhere if the universe was random, right? And they don't. They all fall on a very linear progression from universal size to atomic size. Now, if you look at the differences, if you look at the length between the data points, interestingly, when you subtract the length from each other, you get the phi ratio on that big of a scale. The exact ratio that you find everywhere in nature. The exact ratio that Kepler used to describe the scaling law for our solar system. That scaling law that Kepler came up with by embedding geometries together, which is a crazy idea. It's like, oh, I'm going to embed geometries together and figure out all the orbits of the solar system out of it. It worked. solution is still the most accurate solution at 99.9% accuracy. And it uses a phi ratio. Well, this is like Kepler's scaling law, except it's for the whole universe and everything in it. And it generates the phi ratio, which is the phi ratio we see everything, everywhere in nature. So you know you've got it right. You guys all followed this? Now you start to see yourself as a scale, as a resolution in an infinite scale of space. You are the event horizon, you are the boundary between infinitely big and infinitely small. Go ahead.
Would the biological transmutation of elements fit into this?
The question is, biological transmutation of elements fit into this? It does, because if everything is a black hole at different scale, you should be able to move the scale. If you understand that and you understand the geometry under which that happens, you should be able to move the resolution up and down the scale. And by doing so, you would change the elements. So it is a key component to eventually being able to change one element into another in a laboratory. And we'll see tonight and this afternoon how the ancient alchemist knowledge is directly related to this, and how the geometry of the vacuum function. That's why the alchemists had all this geometry embedded in their knowledge. So this is extremely significant, this scaling law. And it's just about to get published. And we're publishing it first in a very broad peer-reviewed journal, so that we can publish it as a whole with all the writing, because it's fairly long. But as well, we're publishing the solutions, the mathematical solution, in various mathematical journals. And I'm hoping that, I'm sure that it's going to be ignored largely at first, because that's always the way things go. But eventually, it will get noticed, because the solutions are extremely accurate and they work for unification. And this afternoon, we're going to see more of what that means, what is the topology of how that works, and how that relates to ancient civilization. So to finish on this before we go to lunch, this geometry then, the geometry of the collapse, generates all of the scales of the black hole dynamics, each boundary being one of the resolution of the fractal structure, from universal size right down to subatomic particle size. And this geometry is what dictates where the structure occurs, where the boundary occurs. Infinite boundaries within boundaries. Well, that actually happens in a human body. The cells of a human body divide exactly that way as well. So not only does the cell obey the Schwarzschild condition of a black hole, but the cells, I have a little move